Okay, so the last thing we're going to learn about inequalities is how to write them from word problems. So we're going to start with our I can statement. The goal of this lesson is to be able to write an inequality from a word problem. Okay, and then just a reminder of our symbols. This is the less than symbol, the greater than symbol, less than or equal to, and then greater than or equal to. And the symbol always opens to the bigger side. So just like when we were writing equations from word problems, inequalities is going to work a lot the same way. So we're going to pick a letter to represent our unknown value. So our variable. And we're going to write it down and label it. Okay. And I'm going to rewrite this as the cubes method to stay consistent with what we did before. But it'll be the same. We're going to circle numbers in units, box math action words, underline the question, then evaluate and solve. Okay. So I'm going to zoom in. It says, Jim needs to sell at least $500 worth of paper by the end of the week to make his quota. Each ream of paper costs $5.25. How many reams does he need to sell if he has already made $122? So we're going to go through and circle our important numbers first. I see $500, $5.25, and $122. And then U is for underlining our question. How many reams of paper does he need to sell? And then we box our action words. So at least tells me what type of symbol I'm going to use. I see the word each. And then already kind of tells me something to do. Okay. So the money he makes for selling paper plus the money he has already compared to the $500. Okay. So at least 500 means that the smaller side is going to be 500. So it's going to open to the bigger side. The 500 is going to be the smaller one. And at least means it could also be exactly equal to. Okay. So the amount of money he needs to sell in paper is going to be the cost of each ream of paper, which is just a pack of paper, which is the $5.25. Oh, we forgot to pick our variable. Oops. Let me just scooch these guys down. I skipped the most important step. All right, your variable comes from your question. It's asking us how many reams he needs to sell. So I'm going to pick R to represent the number of reams. All right, so then to find the amount of money he has to make, you're going to take the cost per ream, $5.25, times the number of reams, which we don't know, so R, and then plus, He already has $122. Is greater than or equal to his goal of 500. Okay, and now I can solve. So draw a line under your symbol. There's no parentheses, there's no like terms, but I do have a constant, so I'm going to circle my constant, the plus 122. The opposite of adding 122 is subtracting 122. What I do on the side of the variable, I have to do on the other side as well. That cancels these guys out. And I still have 5.25r is greater than or equal. And then 500 minus 122 is 378. Zoom in a little more. Okay. So I undid the constant. Now I have to undo the coefficient. 5.25r means 5.25 times r. The opposite of multiplying is dividing, so we're going to divide both sides by 5.25. So 5.25r divided by 5.25 is just positive 1r. 378 divided by 5.25 is 72. So Jim needs to sell, oh no, got weird. What is happening to the screen? So he needs to sell 72 reams or more. Okay. All right, let's go to the next one. The total area of a house needs to be no more than a total 1,575 square feet. The area of the main house is 1,230 square feet. What could be the maximum square footage of the garage? Okay, so we're going to go through and we're going to circle our important numbers. So 1,575, 1,230. I'm going to box my math action words. I see total area. I see no more than. And I see maximum. Okay. And my question is, what is the maximum square footage of the garage? So that's what I pick my variable to be. I'm going to pick G to represent the area of the garage. Okay. All right, so this total tells me that I'm going to need to add something. The area of the garage plus the area of the house is going to give me that total. Okay. So the area of the garage, we don't know that, so that's where my variable is going to go. G plus the area of the house is 1,230. And that total area can be no more than 1,575. So this total area can't be more than, that means it has to be less than. Okay. but it could also be equal. So the area of the garage plus the area of the house has to be less than the total area given. And now I'm ready to solve. I'm going to undo my constant. The opposite of adding 1,230 is subtracting 1,230. What do I do on the side of the variable? I have to do on the other side. So I'm left with g is less than or equal to 1,575 minus 1,230 is 345. So to answer our question, what's the maximum square footage of the garage? The garage can be 345 square feet or smaller. Alright, so this example is gonna be like the most relevant when you're thinking about budget. So it's the most money you have to spend on something. Or thinking about like how many things can I buy for this much money without going over that amount of money. This is the process you do. This is why we would use inequalities. So it says a phone company charges a monthly fee of $52 and it costs $44.75 per gigabyte of data used. You budgeted $90 per month. What is the maximum number of gigabytes you can use? Okay. Alright, so we're going to circle our numbers. I see $52, $4.75, and $90. And we underline our question. What is the maximum number of gigabytes you can use? And that's where my variable is going to come from. Let's use G to represent the number of gigabytes. All right, and then we box our math action words. I see monthly fee. The word and tells me I'm going to do something. I see the word per. I think that's all I see right now. Okay. So to write my inequality, the amount of money I spend on data plus the amount of money I spend on the fee is going to be somehow related to my budget. Okay. And a budget is the amount of money you set aside for something, and you don't want to spend more than that. So you want everything else to be less than your budget, or it could also be equal to your budget. Sorry. Okay. So you want the amount of money you spend. Could be what you set aside, or it could be less than that, because saving money, always a good idea. Okay. So to find the money I spent on data, I'm going to take how many gigabytes there were, which I didn't know, so my variable G, times the cost per gigabyte. It was $4.75 per gigabyte. The word per tells me I'm going to multiply. So I'm going to take 475 times G, so 4.75 G. Then I'm going to have to add my fee. That fee only happens once a month, that $52. So I'm just going to add it. And I want the amount of money I'm spending to be less than or equal to what I have budgeted, which was $90. So now we're good to go ahead and solve. So I draw a line through my symbol. I have to undo the constant, a number by itself that I'm adding or subtracting to the variable. The opposite of adding 52 is subtracting 52. What I do on the side of the variable, I have to do the same thing on the other side. So 52 minus 52 is 0. These cancel each other out. I still have 4.75 G. My symbol comes straight down, is less than or equal to 90 minus 52 is 38. I'm using a calculator. You just can't see it when I record the videos this way. So I enter my constant. I have to undo my coefficient. 4.75 G means 4.75 times G. The opposite of multiplying is dividing, so I'm going to divide by 4.75. $4.75G divided by 4.75 is 1G. Put my symbol straight down. And then 38 divided by 4.75 is 8. That's a lot of data, yo. So you can use 8 gigabytes or less per month to stay in budget. So a lot of times, like, I will do those things at the grocery store. Like, I have this amount of money set aside for groceries. You know, I need to buy so many cans of soup. I don't know. I can't even think of what groceries I buy. And I just do that process to figure out, okay, how many can I buy to stay within the amount of money I've set aside? All right, last example. David has $40 to spend on flowers. He spends $18 on 2 roses and wants to spend the rest on lilies. If each lily costs $11, what is the most amount of lilies that he can purchase? So I'm going to go through and circle my numbers. I see $40, $18, and $11. And then we underline our question. What is the most amount of lilies that he can purchase? And then we box our math action words. Oh, I forgot to circle. I see the word to. Okay. So I see the word and. I see the word each. I see the word most. Okay. So I'm going to pick a variable based on my question. What is the biggest number of lilies he can purchase? I'm going to use F to represent for flowers. So F is going to represent the number of lilies. Okay. Alright, so the money he spends on lilies plus the money he spends on roses is gonna be related to his total he has to spend. Okay. To find the amount he spent on lilies, it cost $11 for each one, times the number of lilies, which I don't know, so I put my variable there. So 11 times F is 11F. Plus, it said he spent $18 on roses, so plus 18, and he has $40 to spend. Okay. He can't spend more than $40, so what he can spend has to be less than that. Or he could also spend exactly $40. And now I'm ready to solve. Draw a line through your symbol. Circle the constant. 18 is my constant. It's the number I'm adding or subtracting to the variable. The opposite of adding 18 is subtracting 18. What I do on the side of the variable, I have to do on the other side. So I'm left with 11F. My symbol comes straight down, so it's less than or equal to 40 minus 18 is 22. Now I have to undo the coefficient. 11F means 11 times F. The opposite of multiplying is dividing. 11F divided by 11 is 1F, is less than or equal. And then 22 divided by 11 is 2. So David can buy 2 or less lilies to stay in budget. Alright. Thanks for following along. I know that was a long video. Word problems just take a long time to explain. But thanks for sticking in there.